Happy Friday! We'll be going over the remainder of the power chapter, which includes the distribution and management, and then how to create a power budget. So, power management and distribution. Here is a power distribution sample schematic from the ISS. What I've highlighted in red boxes are the distribution and management components. You'll see here that outside the red boxes, we have loads, we have payloads, we have power generation, and we have energy storage. But in between all this stuff, let's just walk through some of the components that are commonly used in power management and distribution and their function. So going from the batteries to this unit over here is a BCDU. So I have a legend. It's a battery charge and discharge unit. So this battery charge and discharge unit regulates the amount of charge rate, or coulomb per second, that is going to and from the batteries. And then we have a DCSU, so a DC switching unit. A DC switching unit, switching being turning something on and off, or doing something more continuous like toggling between different voltage levels. Let's look at this. So SSU, which is between the power generation and the DC switching unit. SSU is a sequential switching unit. So that also, I'm not an electrical engineer, but a switching unit, toggles between different levels of voltage between 0 and whatever maximum voltage. So that feeds into the DCSU, which is a more, we already described, it's taking in DC power. So SSU might be regulating between some variable voltage that the solar cells are giving and feeding it into a more constant DC voltage level. MBSU, what is that? The main bus switching unit. So just another hierarchy above this mid-level switching unit. And then that feeds into a DC to DC converter unit. If you have different incoming DC and outgoing DC voltage levels, then you'll probably need a DC to DC converter. Let's see, then SPDA is a secondary power distribution assembly. So that DC to DC converter unit is likely a feeding at one voltage. So here it says interface A, 123 to 126 volts. This SPDA is going to distribute this voltage and current to many other different sources. So let's see. These RPDAs are remote power distribution assembly. These are like the mid-level distribution units that can take a DC and then convert it to whatever these individual component loads need. Same goes here. And then UOP, utility port outlet, probably specific to the payload. Okay. So maybe what's not covered in that previous schematic diagram are this range of components. So if we break it down, we talked about voltage regulation, which is if a component requires a different incoming voltage than the outgoing voltage from the power source, then you need a regulator in between. If you are worried about the amount of current that something is receiving, there's things called current limiters that protect the downstream component from a surge of current that can, permanently damage the component. Switches toggle voltage or current between 0 and whatever maximum. We've got shunts, which act as releases when you don't want to pass voltage and current through a line. Shunts are very commonly used if you are generating too much power from your solar panels, for example, and your battery cannot handle it. The shunt will, redirect the stream of power into heat or other releases. And then we've just generically have converters. So converters include DC to DC or DC to AC, where AC is alternating current. I hope you know what AC is. Okay, so those are common components. Where do we use those? For source control or power generation, you'll commonly find shunt regulators like we just talked about. If you're generating too much power, you can shunt that away to protect your batteries or energy storage, whatever energy storage you have. And then we have series regulators, which are essentially voltage regulators. If you want to keep a component with some incoming voltage and you want to keep it steady, then that series regulator will help you. And then we've got shorting switch arrays. Yeah, I mean, arrays where you have toggling between on-off for different components. Okay, power conditioning. So if you want your power to be in a different form, whether that be voltage or current or frequency, here we've got these different types of converters. You can toggle between some higher DC level to a lower DC level or vice versa. You can go from a DC voltage to an AC voltage. DC stands for direct current and alternating current. Sorry, so DC to AC changes the way that current is applied. And then we've got regulators, voltage or current. Okay, and then energy storage. We saw in the previous schematic diagram that there are charger and discharger units. That kind of circuitry regulates the way that power goes into an energy storage device and comes out of a storage device. Okay. So hopefully, I understand that this is just a brief overview of the types of components that are involved with power management and distribution. But the next question can be, how do we connect these different components together when we are trying to come up with a subsystem with a certain function? And so I'll wait to do that until later on in the semester when Amber, who is an electrical engineer, can give us a demo of how to design a printed circuit board or a custom board with these components on it. Yeah, I think that typically with CubeSat components, we want it to be as easy as plug and play as possible. So we want to minimize the amount of custom circuitry design. But I mean, for large flagship missions that are very custom when it comes to the payload and all the other components that go inside, it's unavoidable that your interfaces between components will have customized avionics. So yeah, I'm gonna reserve this kind of content for electrical engineering classes. Okay, the one question I got in this section was answered early on.